All right, let's open up to page 175. Before we pick up with this section from yesterday, just want to give you a heads up for a timeline that's going to be happening next week. We are getting towards the end of Unit 3 because we're going to finish this section today, and then we have 2 more sessions to cover, which I think are going to be kind of quick. So I'm anticipating our pass-fail test to be on the 5th next week. I think that's Wednesday? Tuesday. Okay. Everyone should have gotten a copy of the questions. They're the limit ones that we've covered at the beginning of the year, and the answers are available online. Can we get that out just for a second? Do we have that available? Those questions? I had a student in the last class find a typo error on my end, which means one of the questions doesn't make sense. So I just want to make sure that we can fix that. I think I have an extra copy if someone needs it. All right, can you take a look at number 18? It's the graphing example on the front page. It says the graph of a function f of x is shown. Which of the following statements is false? That should read, which of the following statements is true? That makes a big difference.
Will it be fixed on like the test that you give us?
Yes. Yes. So the answer that's online is the correct one if it read which one is true. Okay. But on the test it'll say true. Okay. All right, so pass-fail on Tuesday next week. The day after that, we're going to have our partner quiz for the second half of this Unit 3. And then when you come back from your long weekend because of parent-teacher conferences, we're going to have a test on the 11th and the 12th. Okay? Which means your review day is the 7th, somewhere in there, that Thursday. Okay, so make note of that schedule. Yesterday, we were looking at these derivatives on the calculator, how we can find derivative values, okay, not equations. And I showed you which buttons to press to help you with that. Can we do a refresher from yesterday? We'll do more of it today, but let's just do a refresher. Where can we type in our function to find a derivative value? Math. Number 8. N derivative, okay? And again, depending on your operating system, the newest ones have these little boxes, which are great. If you don't have it, did we figure it out from yesterday? Yeah? Okay. Because Caden has an older model. But it can still work, okay? It still does it. So we're going to type in X for the first box. The next box is the function. So just as an example, we'll do number 1 from yesterday, e to the x, 3e to the x times sine of x. Since we're working with trig, make sure you're in radian mode in this room. Okay, for those of you in physics, you're going to have to switch back and forth. And we specifically want to plug in -2 to find our derivative value. So from yesterday, we got that -0.5381. Okay, we're going to round to 4 decimal places. Now, I want to show you today how you can get this same answer graphically. Okay, maybe you don't want to go through this. Maybe you'd rather see a picture of what's actually going on. So what you can do is hit the y equals button and go ahead and type in the equation. Since we want to plug in -2, you just need to make sure your window for the x's contains that value. So I'll just do -5 to +5 in every direction. All right, so when you hit graph, you should get something like that. Okay. Now we're trying to figure out the slope of this graph specifically at -2. And if you go to that calculate menu that we actually did a lot with last year where we did mins, maxes, intersection points, notice how number 6 says dy over dx. That's one of our symbols for derivative. So if you select option number 6 and you immediately type in -2, notice how it'll choose it as an x value, you can hit enter, and at the bottom of the screen it'll give you the same derivative value. Okay, so you do have another way or capability to find that derivative value on your calculator. You can either do graphically or you can do it on the home screen by using that math command. Okay, so I just wanted to give you another option. All right, we're going to do more with the derivatives on the calculator today, but we're actually going to put some words or scenarios behind it just because we're going to start to see why derivatives are important, or like why or how we use them to make sense of our real world. So up to this point, we've already been discussing how derivative means slope of the tangent line. Are we familiar with another phrase that means slope? If you can think back to Algebra 1. Rise over run. Okay, so slope, same thing as rise over run graphically. Have we heard of rate of change? Yeah, that's another phrase, okay? So whenever you're finding a slope, you're actually finding a rate. And if it's a rate, we're going to have some type of fractional unit. The most common rate we're probably familiar with is miles per hour, okay, for those of us that drive. For those of us that have a little bit more responsibility and we pay close attention to our finances, maybe you're concerned with miles per gallon, okay, for your fuel efficiency, or cost per ounce. Okay, if you go to the Walmart and you take a look at their tags, normally they'll give you the price per ounce or price per unit on their stickers. So those are rates. Okay, those are some type of value that's giving you a rate. So we're going to take a look at how derivatives relate to kind of word problems. We're not necessarily going to be solving word problems just yet. We just want to get used to identifying what these values mean. Okay, what are the correct units? How can we interpret what a value actually represents? Okay, so whenever you're finding a derivative, you're finding the rate at which that function is changing. Okay, whatever that function might represent. So for number 7, we have the number of people entering a concert can be modeled by this function. Okay, so people entering is what this function represents. T represents the number of hours after the gates are open. Can we identify, just so it might help us in the future, what's the independent variable and what's the dependent? In other words, x and y, or in this case, t and f of t. Can we give units to those? What's acting as our x value for this function? T. And what does that t represent? It's your independent, and what's the unit? Time, which is specifically hours for this case. Okay, so t is representing hours. Your dependent, aka y, would be f of t, and what's the unit for that value, or that variable?
5, 6, 3,
People.
There you go.
Okay, remember, people entering is represented by that function. So this might come in handy later. We're going to try to calculate some values. So we're going to first figure out f of a half, but then we're also going to figure out f prime of a half. So we're going to get two different values. We need to interpret what do those values mean in terms of this scenario or in terms of this function. Okay, so we're going to have to use our calculator to help us with this. F of a half, we can go ahead and simply plug in a half for t, okay, into the original function to see what we get out. And let's round it to 4 decimal places. (904-ish) if you type it in. Okay, we want to interpret what does this value mean, okay, in terms of this function, in terms of this scenario. So maybe after we labeled what the variables represent, that might help us out. What does this 904 represent? What do you think, Austin?
That's how many people were in the concert in a half an hour.
In a half hour. Okay, so we'll just round it because you can't have 0.4819 people. So we'll say 904 people in the concert after a half hour. All right, let's go ahead and try to find the derivative, aka the rate. So on the calculator, we'll go to Math, option 8. Okay, this is one way you can do it. You can always graph it the other way. First box is x. Second box is the function. So we'll type in 560 e to the sine x. And we want to plug in 0.5. 793.7573. Alright, so what might this number represent in terms of the problem? Go to Noosh.
At like a half an hour point,
Yep.
around 794 people per hour, I think.
Okay, so this is a rate, meaning we should have some type of fractional unit. So at the 1/2 mark, okay, at that specific moment in time, so at a half hour, the rate at which people enter is 793.7573. What was your units?
People per hour.
People per hour. So how do you know it's people per hour and not hour per people?
Because it's like, look, you have to do the y over the x, like slope.
It's slope. Yep. Okay. So our phrasing for slope, rise over run, rate of change, we had dy over dx in terms of our derivative. So we need the y unit divided by the x unit, aka the dependent unit divided by the independent unit. So we'll have people per hour. So notice the phrasing or the wording's a little bit different as well. So this function value was after a half hour, like after a certain amount of time went on. However, a derivative is at a particular moment in time. So you're not looking over a span of time for a derivative, you're looking at a kind of a snapshot moment. Okay, at this moment in time, at that particular instant, this is the rate at which the people in the concert are changing. Specifically increasing, right? Because the derivative is positive. Okay, so we got to pay attention to the notation. Are we talking about a function value? Or are we talking about a derivative value? Notice how the interpretation changes depending on that number that we have and what it represents. All right, let's try B. How many people have entered the concert after 2 hours? Is the number of people entering the concert increasing or decreasing at that time? Okay, justify your answers. How do you want to go about this one? Well, let's tackle the first one. How can we figure out how many people were in the concert after 2 hours? Plug in 2 to the original function. Notice how they're looking for people. Okay, that's a singular unit. That's not a rate. So we'll just use the original function. So go ahead and plug in 2. All right, so we'll interpret the value. We can say this is 1,390 people after 2 hours. How can we determine if the people entering the concert is increasing or decreasing? Are they coming in quickly? Are they coming in slowly? How can we figure that out? Find the derivative at that point. Okay, so f prime of 2. So on your calculator, we'll hit math. We'll go down to 8. And then let's see, the first box is x. Second box is the function. And we're going to plug in 2. So I got like negative 578 and some change. How can we interpret that value? Good, Austin?
People are coming in slower.
Slower. Okay, so at 2 hours, the rate at which people enter. Okay, notice how I'm using the phrasing from the question. At the very top it says the number of people entering the concert, so that's what I'm using for my justification here. At 2 hours, the rate at which people enter, Austin said it's coming in slower, so we can say decreasing. The rate at which people enter is decreasing at a rate of 578.5451, and our units will be people per hour. So one thing to note here, notice how when I specifically state the word decreasing, I do not have to include the negative in the value, because the negative is just symbolizing that we are going down. If you said decreasing at a rate of negative 578, that double negative would actually mean you're increasing. Does that make sense? So you got to be careful on how you phrase it or write it. Yes?
Does that mean that's how many people are leaving?
How many people have entered the concert? No.
It should be a negative number
That just
on
means
the
that there's not as many people
There's not as many people coming
coming.
in.
Really.
Yeah. So,
It's still above the x hat.
How?
so, because this function models people entering,
Yeah, people aren't leaving. That's just the number of people coming in.
so the people enter is decreasing at that rate. So they're just coming in less quickly than they were probably a moment prior. Okay, they're still entering the concert, they're just entering slowly. All right, are we doing okay so far? It can get tricky with the interpretation. Okay, we're going to try another one. Let's look at 8. After being poured into a cup, coffee cools so that its temperature, represented by this function, okay, is measured in minutes, and temperature is measured in degrees Fahrenheit. So maybe we can label our values here. So independent variable is T, which is minutes, and dependent variable is capital T of T, which is degree Fahrenheit. Okay, so that's like your X and your Y, independent, dependent. What is the temperature of the coffee 5 minutes after it has been poured into the cup? Are we looking for a function value or a derivative value?
Function.
Function. What is the temperature? Okay, a singular unit. And notice how that is our dependent unit. So we'll plug in 5 and see what we get. 79 and some change. Okay, so this is the temperature of the coffee after 5 minutes of being in the room. D, on the other hand, is a little bit different. Is the temperature decreasing faster at 1 minute or 3 minutes? How can we figure that out? Derivative. Okay, that word decreasing, kind of a hint to that. So we're going to figure out t prime of 1, and we'll have to compare it to t prime of 3. So we're going to type it in twice. We'll do math 8. This might actually be a good time to go over rounding. On the AP exam, when we round to 4 decimal places, you can either round or truncate. Do you know what truncate means? Like cut it off. So you can either do 2721 and just cut it off at that 4th value, or you can do 2722 because the 5 would round it up. So they'll accept either one. You can either chop it or round it. It doesn't matter. Okay, can we get those values? Yeah? Can we put units on them like we did the previous one? If this is a derivative, this is a rate, so we're going to need a fractional unit.
Degrees Fahrenheit per minute.
There we go. Temperature per minute. Fahrenheit per minute. Okay, so it's a rate, it's a slope. We need the y unit over the x unit. So that would be dependent over independent. Okay, y over x. So when is it decreasing the fastest? After 1 minute or 3 minutes?
1 minute.
Why?
Because the slope is greater and the rate of change is greater.
The rate of change is greater. Okay, so we'll say at 1 minute because the rate of change. Now, we got to work on the wording. If you say the rate of change is greater, is negative 33 greater than negative 12? It's actually less than. Okay, so we have to be a little bit. Austin, I understand what you mean, but we got to be careful with how we phrase it. The rate of change is decreases faster. We can say the rate of change is more negative, okay, the decreasing faster. You could say because the rate of change of 33.3592 is greater than 12.272, like if you just ignore the negatives. So we gotta, I understand what you mean, but we gotta make sure we're mathematically accurate in how we phrase it. So at 1 minute, because the rate of change is, I'm just going to say more negative. Okay, decreasing faster, that's fine. It's more negative. We'll say 33.3592 is greater than 12.2722. You could say that. Okay, either one of those is good. Okay. Yeah.
I'm still confused about the last one.
It's still not resonating with you.
So
Okay.
if it's a number of people, if F of T is number of people entering, then why do we say that 904.41 or 4819 is the people in the concert? So like if the function is the people entering, why is it the people in the concert?
Okay, so you don't like the word in? We'll do enter.
So then, like, what does the slope represent then?
This
Yeah.
is the rate at which people are entering.
The rate of
So is that 792 people an hour?
Per hour.
But there's 904 people in the concert.
Yeah. So at
It's not an hour.
You're right. So after 30 minutes, this is how many people are currently in the building, but this is the rate at which people are entering at that time. So at the half-hour mark, there's about this many people coming in through all the gates. Okay, at that moment, like if you were to take a snapshot, that's how many people would be standing in line coming in at that point. Okay, the rate at which they're entering.
Well,
So
what's confusing me was whenever I graphed it,
yeah,
the max value, or it was higher at 1.5 than it was at 2.
okay.
So that means that there's less people at 2 hours than there was at 1.5 hours. So wouldn't that mean that people have left?
So is that because you're thinking that's because it's negative? So this, at 2 hour, the rate at which people, enter is decreasing. I think this means people are still entering, they're just not coming in as quickly as they were previously.
But then how do we have less people than we did a half hour ago?
There's more people.
Just accept the
Oh,
problem.
Oh, hold
Accept the
on. No, hold on.
Don't accept
No. Let me graph.
I'm just saying, if you do f of
Take the
1.5,
L.
Yeah.
f of 1.5 is more than f of 2. So wouldn't that mean that people have left?
People, yeah. I think,
So you've reached the max. So that means there's no way that more people could be coming in, right?
Yeah, I mean,
Okay.
there could be more people coming in, but more people are leaving than are coming in.
yeah, but this function is only about people entering. This function will give us no information about people leaving.
People leaving.
Why is it negative?
The rate,
People are coming in
slow,
so slowly
slow.
that it's
Yeah.
a negative number.
That's a negative number.
Doesn't even make sense.
But if more people are leaving than are coming in,
We don't, this is just the number of people entering. Like we don't know the rate.
so that can still be that if the number of people leaving is greater, but we don't know the number of people.
We don't know the number of people leaving. Yeah. So we could have less people in the actual auditorium or concert, but we don't know the information of the people leaving. So this is the rate that they're entering. It's very negative, so they're coming in very slowly. Okay. Okay. So if you take a look at the wording, this.
That wouldn't be a negative number, Stewie.
That would be a
No, it wouldn't. Stewie, one person every 5 minutes is one bit. That's still not a negative number.
You're just gonna get a really
Where's
small
your negative number, buddy? Why is there a negative number? That's what we're talking about. No, we don't know wrong. No, that's
What are we thinking?
I was thinking.
No, I know what you're saying.
I can't hear. No, I can't hear him. I can't hear him. What were you thinking? Well, no. Now I want to know.
That's what I thought.
Okay, it was confusing.
Yeah.
Getting like a number really close to 0 but still positive, like 1/60. I think
Yeah.
that's your example.
Uh-huh.
Versus a negative
But what my
number.
thought process was, is if like 60 people come in an hour,
Yeah.
there needs to be 1 person a minute. So if at that minute less than 1 person is coming in, the number would be negative, the rate? Or is that
It
not?
would just be a fraction.
It'd be a fraction. Yeah.
So positive.
At least I have an idea.
Okay, good job.
So wait, how can you have negative people?
Yeah, but it's completely wrong.
No, it's not that
What do you have?
But
I-
if one person were to come in every 200 years, it would still be a fraction, not negative.
No, it's the rate.
Yeah.
It's the rate.
People are, it's not
Wait,
the
what?
sheer number.
Right.
I know. That's not what I'm saying. If the
No,
rate,
that's not what you're saying.
If the rate is really slow,
so
we're not
we're only
talking
talking about entering. We
Yeah.
can't know anything about anybody
That's
leaving.
disturbing my
Which
life.
means that
I'm just gonna use that like-
coming
So
in
why
really
wouldn't- why
slow
wouldn't the
has to
rate be
what
like
you're saying, it has to
a
be-
small
No,
positive
yeah,
number?
but
If
Yes,
not very
I'm
many
saying
people are
that's
coming in.
negative, because it's-
Well, hold on. Let's think about this. If your slope is 0, aka your rate is 0, you're not changing, right? Okay. So if the rate was 0, that means nobody's coming in. Okay. So then if the slope is negative, but they can't be leaving because this is representing entering. Oh
We
man.
know nothing about entering
We-
in this question.
Okay.
We know nothing about leaving.
We don't know anything about leaving.
More people leaving than entering.
how do you negative?
But then a negative number doesn't make sense. in
Look,
this
just look at
doesn't
the,
make
just look. Is the number, guys? Look at the question. Is the number of people entering increasing or decreasing at this time. So you're still entering the concert. It's just the rate at which you are entering. You're slowing down. The rate at which people are coming in is slowing down than a previous point in time. Okay, so it's not about the number of people entering, it's the rate at which they're entering. Okay, the rate is slowing down. Because if you think about the scenario, the closer you are to the time at which the concert starts, there should be less people coming in because everyone's already in.
They want their seat.
They want their seat, exactly. So if the moment you get closer to perhaps the concert time, the rate at which people come in is going to be slower and slower and slower. Okay, it's a negative rate. You're decreasing. The number
Decreasing
from the original, right?
This question probably should have been worded as the number of people in a concert, because it seems like we're describing a rate as the function value.
Yeah.
And then
Yeah,
the derivative of a rate seems like it would be the second derivative
Ma-
of the people inside.
Right.
That makes a little more sense.
I think you're.
Yeah, I think that the question probably should be worded as the number of people in a concert.
In a concert.
Because the function is the amount of people in the
Okay.
concert.
Well, maybe for next year I'll change the word. I don't know. Okay. Number of people entering. Can we, Griffin? Can we wrap our mind around that yet? Okay. All right. Let's go ahead and try some more. We're just getting used to identifying what these values mean. All right. An ice cream company on the next page. An ice cream company knows the cost in dollars to produce Q quarts of cookie dough ice cream. Oh, that sounds good. All right, so C equals F of Q. It's a function of quarts. If F of 200 is 70, explain exactly what that notation means. So can we label independent, dependent variables and units? What's acting as our X? Instead of F of X, notice how it's F of Q. So independent would be Q, which would be quarts. And then the dependent is the C, which would be the cost in dollars. All right, so what's that notation mean? Go to Noosh.
It costs the company $70 to make 200 quarts.
All right. It costs the company $70 to produce 200 quarts.
I wish I could buy 200 quarts for $70.
Me too.
You get a DQ. Oh my god. You get a DQ to get one medium blizzard and it's like
4 quarts is a gallon,
it's
right?
like $5.
Yep. 4 quarts is a gallon.
That's 50 gallons of ice cream.
But you get a DQ, you buy a little medium blizzard and it's $5.
I know.
That's true. It's a better deal.
It's a better
I'm not
deal.
sure about the $70 on 50 gallons
I
of
could
ice cream.
totally-
I wish that was the same rate for
200 gallons.
It's 200 quarts.
200 quarts.
50
Oh,
gallons.
okay.
What about the next one? F prime of 200 equals 3. F prime of 200 equals 3. You want to give it a Noosh? Give it a shot?
So maybe like at creating like 200 quarts of ice cream. it
Okay.
costs them $3.
So when 200 quarts are produced, okay, did you go on from there?
Oh yeah. When 200 quarts are produced, it costs the company $3 per quart. No, after that, I don't know.
That's what I was thinking. I'm not gonna lie, I was on the same way.
It's a rate, because it's a derivative. When 200 quarts are produced, let's look at the wording. Okay, an ice cream company knows the cost to produce that many quarts. Okay, so when 200 quarts are produced, the cost of production is increasing, decreasing? Is increasing at a rate of $3 what per what? Dollars per quart. Okay. So maybe producing 200 quarts is not as efficient because the cost of production's increasing. You want to try to make that as minimal as possible, right? So at that moment in time, when they produce 200 quarts, this is the rate at which they're costing their company some money. Okay, $3 per quart. Good. All right, let's try the next one. Let F of t be the amount of rain in inches that has fallen since midnight, where t is the number in hours since midnight. Complete the following interpretations. So independent, dependent, what's acting as our x? T, time, and the unit is hours. And the dependent would be f of t, and a unit would be inches. Okay. Amount of rain in inches that have fallen since midnight. Okay. What about A? F of 10 equals 3.1? Go ahead, Christian.
After 10 hours, there have been 3.1 inches of rainfall.
After 10 hours, well, let's say it has rained. Okay, after 10 hours, it has rained 3.1 inches. Okay. What about B? What do you think, Austin?
In 10 hours, the rate at which rain falls is 16 inches per hour.
Okay. What's that little negative power mean?
So wait, does that mean
This is not a prime, right? That's not a derivative. What's the -1 power mean?
Inverse.
Inverse.
So does that mean that 16 hours? 10
The X and the Y switch. After 16 hours, it has rained 10 inches. Right, inverse, switching X's and Y's, we're going to take a look at that in a few sections. Okay. Now what about C, now that we have the prime? You want to try it, Austin?
Yeah.
Okay.
In 8 hours, the rate of which rain falls is 0.4 inches.
The rate of rainfall is 0.4. What was your units?
Inches per hour.
Inches per hour. Are we gaining rain?
Yes.
Yes. Okay. Now, let's think about it this way. If this was a negative rate, would we be losing rain?
Heck yeah, we would.
Would it be evaporating?
Yo.
No. Right? Here's that negative thing again. If this is a negative rate, you are raining slower. Okay? This would be a better example. So if this was a negative rate, it's not saying you're losing rain. If it's a negative rate, you're raining slower. Okay, the rate of rainfall. Maybe that's a better example. All right. We'll save the last one for tomorrow as a review. Okay?
I think the F prime T needs to be installed.
Yes.